All right, so we just had a little bit of 3.3 left, so we're just gonna finish that up. Okay, so when we met last time, we entered this whole new radian world, right? And we converted from degrees to radians to degrees, right? And I really showed you the correlation of all that. We even looked at our unit circle. That's on the very back of your notes, I think. And then we started doing without our calculator what we did in degrees, but now we're just doing in radians, right? So we draw the angle. That's when we were really using the fact that this has to say pi, right? So if my reference angle is pi over 6, this has to say 6 pi over 6. So we know that 5 pi over 6 would be 1 back in that quadrant. All students take calculus, figuring out your sine, and then finding the value of your reference angle. So for number 1, we said it was pi over 6. So we go to our 30-degree triangle, and we do cosine, so adjacent over hypotenuse. That was kind of where we left off. Of course, this is things that we're going to draw in our test, right? And then we did some work with our quadrantals. And remember, our whole thing there is that sine is y and cosine is x, right? So if you can remember that, you're just looking at these points there, okay? So what we're going to do is some more of these examples of just using, not using our calculator, using our triangles in the radian world instead of degree world. So if I'm going to do cosine of 5 pi over 6, I'm going to draw my angle. So if I'm thinking writing pi with a denominator of 6, this would be 6 pi over 6. So 5 pi over 6 would be here. Okay, and then all students take calculus. That would tell me that cosine is negative there. And then your reference angle, remember, is a little bit easier to find when you are in radians because it's just that little piece. So your reference angle is pi over 6, which is 30 degrees. So you would go to your triangle and do cosine. So this would be, adjacent over hypotenuse. So that's the square root of 3 over 2. And of course it's negative because we already said that. Okay. Next one, tangent of 4 pi over 3. All right, so we would make this 3 pi over 3, so it would still say pi. So 4 pi over 3 would be there. That is all students take calculus, so that's in the third one, so this is positive. And then my reference angle is pi over 3. So that's my 60-degree triangle. And I'm going to do tangent, so that's opposite. Keep clicking that. Opposite over adjacent, so the square root of 3. Like that. Okay. Next one. The sine of negative pi over 3, I want you to think about what would positive pi over 3 look like, right? You should, hopefully by now, we're getting close to being able to just say, okay, that's 60 degrees. So that this would be positive 60 degrees, of course. So we're just going in the negative direction. 60 degrees or pi over 3. Okay, so those work the same way as our degrees do in terms of going the other way. Okay, that is just negative 60 degrees. All right, so of course your reference angle is easy for this one. It's just pi over 3. We are going to be negative because we're in the fourth quadrant. And then the sine of pi over 3 is the square root of 3 over 2. So you would go to your triangle and do opposite over hypotenuse, like that. Okay. This one, cotangent of 7 pi over 6. This would be 6 pi over 6. So here's 7 pi over 6. Okay, we're in the third quadrant. Tangent is positive in the third quadrant, so is cotangent, right? Our reciprocals are also positive. Our reference angle is pi over 6. So we're going to go to our triangle, and we're going to do, I would do tangent and flip it. That's just easier for me to remember. So we're going to go to, I gotta find my triangle. There we go. Our 30 degree, and we're going to do tangent. So that would be 1 over the square root of 3, and then I'm going to flip it. So the square root of 3 over 1. So just square root of 3. If you don't want to do that, tangent is adjacent over opposite instead of opposite over adjacent like tangent is. Okay, let's skip to this one. All right, 7 pi over 4. All right, we have to draw that. This would be 4 pi over 4 because it would need to say pi. So over here at 2 pi, if this needs to say 2 pi, but I need to write it with a denominator of 4, I'm going to write it like 8 pi over 4. Okay, hopefully you can see that that is still just 2 pi, right? That's still just 2 pi. So 1 back from that would be 7 pi over 4. So we're in the fourth quadrant, that's negative for sine. And then reference angle is pi over 4. So we go here, so this is pi over 4. And then we do sine, so that's opposite over hypotenuse, 1 over the square root of 2. Just like that. Okay, so hopefully these are making a little bit more sense to you guys. I know it is different from our degrees, but hopefully you can see the similarities of we're drawing that angle, using the quadrant to find our sine, and using our triangles to find the value. Okay. Now we're going to talk a little bit about using our calculator. So we've kind of done the same thing with radians and degrees. With degrees, we didn't use our calculator, and we drew the angle, we found our reference angle, worried about our sine, and we've done that with radians. Also with degrees, we had to do some calculator work, right? So here's what we're going to do that here, right? But we're going to change our calculator to radian mode. So I have pictures here, because I obviously can't show you. You have this DRG button right next to the second button on both calculators. If you clicked that, it would give you 3 options. So right now, you would need to go over to the RAD button and then press enter. And then you should see down here RAD, right? So that means you're in radian mode for all of these. And for most of these, you're just going to type them in your calculator. And this little guide is supposed to be over here on the pi. So I need to fix that in your notes. But for the most part, you really are just plugging them into your calculator. So sine of 12, you just press sine 12 and enter, and you should get negative 0.537. Same thing with number 2. You have a pi button right above that little arrow right here, and then right here. So same spot on both calculators. So you would hit sine 7, your pi button divided by 4, and then close your parentheses, and you should get negative 0.707. Okay, we're going to go to number 4. Same thing. You're going to do that same thing. But this time it's the same angle. So they're both 7 pi over 4, but it's just cosine 0.707, which is actually 1 over the square root of 2. So we could use our triangles for that one. And we did just a second ago. We actually used our triangles to solve sine of 7 pi over 4, I believe. So these buttons over here, or these right here, the number 3 and number 5, we don't have a cotangent button and we don't have a secant button, right? So those little stars, well, it's supposed to have stars, these little stars right here, that's when we use our reciprocal button. So it's either going to look like this or like this. So you're going to use these keys for reciprocal. Okay, because you don't have a cotangent button, but you could hit tangent, right, the reciprocal. You do have that button, tangent 9, enter, and then you're going to hit your, on this calculator, you would hit this button right above the 7, and then you would hit this button on the other one, 1 divided by x, two buttons above the 7, and then press enter. And you should get negative 2.211. Okay? So you're just doing the reciprocal. So this secant one, we can do this one. The reciprocal of secant is cosine. So I'm going to do cosine of negative 2.805 and press enter. Then I'm going to hit my reciprocal key and press enter. And I get negative 1.059. Okay. Just like that. So all of those are just making sure that you are in radian mode, and then you might have to use your reciprocal key. On your test, it's going to be, what's kind of tricky about it is if it doesn't, you're going to have to switch back and forth to degrees and radians and things like that. They're going to be all mixed up. So you just have to make sure if there's no degree sign that you are in radian mode. Okay. This next part, we did this with our degrees. Now we're going to do it in radians. And then on your test, I would say find theta in radians, find theta in degrees. That's how you know what mode that you would need to be in, okay? And anytime we are trying to find theta, find the angle, we're going to use our second trig function key. So for this one, these are the ones where we had to multiply by on both sides by the inverse, right? Because that just leaves us with theta. So you would type in second sine 0.3210, and theta is 0.327. So just using that reciprocal key, not reciprocal, inverse key. So I'm going to write these down. So second cosine, 0.785, and then second tangent. So you have all of those buttons, which is great. So you just have to do second, whatever trig function you have. Okay, so write all those down. And then this one, we don't have that button. You can't press second cosecant, right? We don't have that button. Okay, but the reciprocal of cosecant is sine, right? So we know that sine theta is 1 over cosecant theta, right? That's what reciprocal means, right? That's why we say flip it, because it's 1 over that. And I know that this right here equals negative 2.14. So I can say this is 1 over negative 2.14. I can just plug that into my calculator. 1 divided by negative 2.14, and I get negative -0.4679, okay? I didn't use any trig button key. All I did was 1 divided by -2.14, and I got this number right here. So sine theta equals this over here. So I could write it like sine theta equals -0.4679. I do have a sine button, right? So I could type in this guy, second sine, and then I'll get my answer. And you should get -0.486, like that. Okay, so all of this work over here was because I don't have this button. I don't have a cosecant button, but I know that sine, which is the reciprocal of cosecant, is 1 over cosecant, and I do know what cosecant theta equals. It equals -2.14, right? So I did 1 divided by that, and then now I have sine theta equals something, and I can use this, okay? That's exactly what we did for degrees. The only difference in any of this stuff right here is what mode I was in. Okay, all of it, all of the process is the same, okay? And then we just have these two where we are looking for theta again, right? So I want to know, find theta over this interval, okay? So this is an interval notation type of thing, such that cosine theta is -1/2. So we are just going to work backwards, okay? What we have done is we have found the value, not the angle. So we've been looking for this, not this. We've been given this and looking for this. So now we're just going to do it the other way. So we're going to draw a quadrant. Okay. If cosine is negative over this interval right here, okay, pi over 2 is 90 degrees. And pi is over here at 180. If I am only in this interval, that means I am only in this quadrant. I am not looking for the angle here, here, or here because of my interval, right? So I'm just looking for this angle right there. All right? So if cosine is 1/2, right, it would be really helpful if I knew a reference angle, right? If cosine is 1/2, and this is pi over 6, pi over 3, sorry. Pi over 3, pi over 6 is 30. Okay? I need to go do cosine and get 1/2. Do you see that that is pi over 3? That would be my reference angle. Okay? If I went here first and did cosine, I would get square root 3 over 2. So it's not that one. And of course, it's not going to be this one. So it's going to be pi over 3. Well, if that's pi over 3, then this has to say 3 pi over 3. So 1 back from that, right? My answer would be 2 pi over 3. So what I'm saying is that the cosine of 2 pi over 3 is -1/2, right? Normally, what we've done previously at the beginning of this section was we had cosine of 2 pi over 3 equals what? So we did it backwards, right? Okay, one more. This says find theta over the interval 0 to 2 pi. So now I'm all the way around my circle, right? such that sine theta is negative square root 3 over 2. So I have my quadrant here. If sine is negative, right, and I'm 0 to 2 pi, so I'm all four quadrants. If sine is negative, it has to be here. And here. So I'm looking for this angle and the blue one, that angle. It can't be here and here because sine is positive there and there, right? So I'm going to find my reference angle. I'm going to go to my triangles. And I'm going to do sine, and I need to get the square root of 3 over 2. Again, if I went here first, sine would give me a half. That's not right. If I did here, sine would give me square root 3 over 2. So pi over 3 again. So this would make this 3 pi over 3. And then it would make, at 2 pi, it would make it 6 pi over 3 because it needs to say 2 pi. So that light blue angle would be 1 forward, so 4 pi over 3. And then my green would be 1 back from 6 pi over 3, so 5 pi over 3. So both of these angles are the answer. Again, I could plug both of them in for theta and get negative square root 3 over 2. Okay? And that is all of section 3.3. So now you guys could go do your homework.